Electricity. The term electric is basically originated from Greek word electron. Electron in Greek stands for amber. You see, in electricity, we study regarding the properties associated with the charges. Again, we classify the whole thing in two parts. One, while the charge is stationary, and the other while the charge is moving. A stationary charge we take into branch electrostatics. What's electrostatics? In which we study about the properties associated with the charge at rest. Here in this chapter, in this branch, we study regarding electric force, electric field, electric lines of force, electric potential and capacity. In electrodynamics, we deal with the properties that are related with the charge in motion. When the charge is in motion, we use the term electric current. In the branch electrodynamics, we study electric current, current density, the conduction in metals and drift velocity, resistance and their combination, cells and their combination, Wheatstone bridge and Kirchhoff's law. Now, we will start electrostatics, in which we will study only stationary charges. First of all, let us talk about Coulomb's law. Two charges placed at distance r, force between them proportional to their product, proportional to inverse of square of distance between them. On combining, you get q₁ q₂ by r square, and then you use the proportionality constant. This is known as Coulomb's constant, this one, Coulomb's constant. When you are talking about free space, this Coulomb's constant will be equal to 1 by 4 pi epsilon 0. You see, here we are considering only free space. This value is in SI, and the same thing becomes 1 in CGS. What do we mean by CGS while dealing with electricity? I told you, stat coulomb, the unit of charge, and the unit of distance, centimeter, then only you could say this is CGS system, force would be taken in dyne. But when you are considering all the units SI, then you need use this relation K equal to this much. Coulomb's law we have covered. This 1 by 4 pi epsilon 0, that is the value of Coulomb's constant. This is equal to this much Newton meter square per Coulomb square. And if there is some medium, then in place of epsilon naught that is known as permittivity of free space, means when there is no medium between the charges, in that case you would use here epsilon naught. Epsilon naught has the value 8.854, 8.854 into 10 to the power minus 12, this thing. But this is approximated to 8.85 only, up to 2 decimal places. Suppose there is some medium, then you would prefer epsilon. Epsilon stands for permittivity of any medium, and that could be written as epsilon naught into K, or better you write K as the ratio of these two. Permittivity of a medium, permittivity of free space. This ratio is known as dielectric constant. This is also known as relative permittivity, and above all, this is also known as specific inductive capacity. That for the medium this term is used. Electric force, that is conservative in nature. Conservative means it follows inverse square law, and there is no loss of kinetic energy because of this force. This force is also central in nature, that means it is directed to the origin from where it is started. Electrical force is central in nature. It simply means that it is directed to the object or the source from which it is being applied. Gravitational, electrical and magnetic, these forces are central in nature, and once you say that the given force is central, it means it can be have as centripetal. You see, nuclear force is non-central, that is not directed to a particular point. You use free space between the two charges, then in that case the formula would be 1 by 4 pi epsilon naught q₁ q₂ upon r square, and if there is medium, then in that case it is going to be 4 pi epsilon naught k q₁ q₂ upon r square. What does it mean? When some medium is introduced, remember here I am talking about the full insertion of the slab between the two charges. In that case, the force is reduced to 1 by k times the initial value. Initial value here we mean that the force that was existing when there was no medium between them. One very important characteristic of electric force is also that it is not going to be affected by any introduction of additional charge surrounding it. You see, all the nature I have told you. One very important thing is that this force is considered as electromagnetic. Forces are basically of four types: gravitational, nuclear and weak force. Now, what other forces other than these three are always categorized in electromagnetic type. The family of electromagnetic forces is the biggest one. Electrical force, magnetic force, these are forces of electromagnetic nature. This we have done. Permittivity, the ratio of medium and that of the free space, that is known as relative permittivity. This value is 1 for free space, you might say. This is infinite for metals, and all other media, means any gas, any vapor, you are going to have the value of k greater than 1. For example, when you consider air, it is 1.00059, this one. For water vapor, it is going to be 60. For water itself, k is equal to 80. The maximum value of k goes to 1000 times also. Then two cases we have covered. One is free space between the two charges. The other is when it is fully inserted by some dielectric slab, some insulator. Two cases we have covered, and now the term is that for partial introduction of some medium between the two charges. Suppose the charges are q₁, q₂, are distance apart, and in between them you are going to introduce a slab of thickness T having the dielectric constant K. This slab of thickness T having the dielectric constant K, here R minus T distance is that of air, and this is that of slab. Thickness of slab is T. So, it will be facilitated if we could have an equivalent distance in air for this very slab. That means we want equivalent air distance for T thickness of slab, and this is going to be T root K. Once again, I would try to make it crystal clear that this slab is having thickness T, and you just want to forget it and you want to replace this by air. you can use the air column of thickness T root K. This was the thickness of actual air, and this comes to be the equivalent. Now, the effective air distance you might consider is R minus T plus T root K. Means you will forget here that slab is there. Simply you would recall that air is of this very thickness and you will proceed. This is how we replace the given distance of the slab by the air column.